Some polynomials can be factored into perfect squares. In this case, we can see that x squared is x times x, and 9 is 3 times 3, making the first and the third terms perfect squares. And the middle term is twice the product of one factor from each of these perfect squares. Because of this, we can recognize this trinomial as a perfect square trinomial, which can be factored into a plus b squared. Here, a is x, and b is 3, so the factored form is x plus 3 squared. Let's break down this trinomial, 4x squared minus 20x plus 25. First, notice that the first term, 4x squared, is a perfect square, as it can be written as 2x times 2x. And the third term, 25, is also a perfect square, which can be written as 5 times 5. However, since I see that the middle term is negative, I can express 25 as negative 5 times negative 5, because squaring a negative number also gives a positive result. Next, notice that the middle term, negative 20x, is twice the product of the factors from the first and third terms, following the pattern of a perfect square trinomial. Therefore, we can factor this trinomial as a square of a binomial, where a is 2x and b is negative 5. So the factored form is 2x minus 5 squared. Another special polynomial is a difference of two squares. If the two terms are perfect squares subtracted from each other, we can factor it as a plus b times a minus b. Let's break down each term of this polynomial. The first term, 16x squared, is a perfect square because it can be written as 4x times 4x. And the second term, 81, is also a perfect square, as it can be written as 9 times 9. Since these perfect squares are subtracted from each other, this follows the pattern of the difference of two squares. Therefore, we can factor it as a plus b times a minus b, where a is 4x and b is 9. So the factored form is 4x plus 9 times 4x minus 9.